So I'd like to thank our panelists. I'll give you a formal introduction in just a moment, but I'd like to thank them for taking time to join us today. We have Matilda Gronke, Sharon Cho, Tim Blas, Lucas Lukaziak. And let me give you a little information about them. So Matilda is a senior research data scientist. Finding and sharing the stories hidden in data is her passion. I think it's one that we probably share, and she's at Axilla Healthcare, as you heard before. She applies her scientific understanding to the largest pain database in the world. Is that right? You think? Quite possibly. 100 million. If anyone has a larger data set on pain, raise your hand. Okay, certainly largest in this room. You earned your PhD in physics from Paris University, and you've worked, published, and presented internationally. Her career really is around understanding biomechanisms behind bone fragility and improving early diagnosis of bone disease. And previously, you were here at Vanderbilt at the Medical Center. So welcome back, and thank you for joining us on the panel. Sharon Cho is a principal data scientist at Mira Learning. It's an early-stage, venture-funded startup in educational technology. She's an intelligent digital tutor. Mira is an intelligent digital tutor that encompasses machine learning and various modalities. Prior to this, though, you'd worked in predictive analytics to optimize user experience and tech support and forecasting energy use. And that was something that struck me about your background, how varied the fields are that you've applied machine learning, deep learning, and data science. You have your engineering degree from MIT and PhD from Stanford, and your research spans across topics. So you have nanoscale circuit design, is that right? And also statistical methods and quantum chemistry. And you've worked in large companies and small companies, but is this your first kind of startup company? Okay, so kind of the first startup, so great. Tim Blas, in a local company here, Digital Reasoning. You're lead data scientist for the financial services, and I know that's a big book of work for Digital Reasoning. You work with some of the world's largest banks to mitigate unlawful behavior by following communications, is that right? And you use natural language processing to detect suspicious behavior and to raise alerts for internal compliance teams. But your background, your PhD is in mathematics from University of Texas in Austin, and you were a postdoctoral researcher at Carnegie Mellon and an assistant professor at University of California, Riverside. And so your research has combined theoretical and computational methods and focus on mathematical modeling in materials science. And previously you were at Capital One, is that right, as their principal data scientist. And Lucas, actually I've known Lucas for a number of years now. I'm trying to think back, but it's been quite some time. But is a newly appointed director of healthcare analytics at Change Healthcare, a large data science team that you're leading there. And it's applied data science initiatives to improve and develop new data products that help healthcare payers optimize networks and effectively expand value-based payment models. So you previously had won the Change Healthcare Pinnacle Award, and is that kind of the highest award that they have for technical innovation? Yeah, very good. You are also, very importantly, one of the principal organizers of Greater Nashville Healthcare Analytics Group, and over 1,300 members now, which is amazing to think. You have a degree in physics and computer science, and you've done coursework in data science at the Johns Hopkins Public School of Health. So thank you all very much for taking some of your time. A couple of quick ground rules. We're going to be taking questions from the audience. Also, I have some questions that I'd like to ask. I'd like to ask our panelists to use one of the two microphones. Go ahead and get intimate with the microphone because it doesn't work very far away. So just go and speak directly into it, and it'll be safe. It'll be fine. So let me go and start off with a question for the panel. So what tools, platforms, or advancements have been most disruptive in your work just in the last year? Who'd like to go first? Matilda? You made the mistake of looking over here when I was...
All right. Can everybody hear me? Yeah. The data scientists at Axial Healthcare have just split into two teams. So one team is more focused towards developing new products for the clients, and I moved with a team where my clients are internal clients, so it's other teams, business development and that kind of thing. So what I've been discovering, what has been really changing my life the last 3 months is actually using dashboards, like creating dashboards, and like the whole aspect of data visualization. Especially in academic, you're usually surrounded with people who understand what you're doing, but when you have to explain your findings to people who have no science background or anything like that, you really need to work on that. And so how do you best convey your results if you want them to be meaningful? So yeah, I'm using R, so R Markdown is really helpful in Shiny app, basically to convey your results. It's really something that's been changing my life the last few weeks. So.
Hi, so at Mira Learning, it's a company that just started last June. So we had no code at all, and I personally have been getting more, I would say, intimate with GitHub, Git, and Amazon Web Services. So just simply starting Git repos for us was a big step, and it was to organize all of the algorithm design ideas that were not previously in code form, and it was not reproducible. And so, yeah, when we started the Git repo, it was suddenly reproducible, and we can track back to make sure that all the models that we were designing, we know all the hyperparameters and all the input data now has version control, and in a remote team such as ourselves, so we are spread across different cities in the US. And so this is a big thing because we also needed to overcome that barrier of learning to communicate through Slack and not in person in an office.
Can you hear me? Hear me okay? So yeah, actually, I guess two things. One, a bit like the Git experience where you have the reproducibility. We had been using Git for a lot of things, but some stuff wasn't as standardized, so moving everything to a standardized process and repo was important for us. Also, one thing on top of that was getting experiments run in containers, so you've also got like another level of reproducibility, so you're not relying on different people's setups affecting the way that experiments are run. One other thing that's sort of in the front of my mind for like disruptive technologies and NLP is also like the pre-trained language models that have been coming out lately. So there's a lot of work at different committees, building out these massive models that you can then take and then sort of fine-tune your problem to build off of what they have. And you don't necessarily need all the resources that they had to build that out. You can kind of work off of what they've been doing. I think that's a very important step for NLP.
Hello. At Change Healthcare, we have a lot of the data. We have one of the major healthcare switches, so a lot of the data between all the payers, providers, labs, pharmacies come through our switch, and there's a lot of data we have rights to. We work with most of the hospitals and many of the payers in the healthcare system. So I would say the disruptive thing we saw this year, really in the last 6 months, is TensorFlow coming out of the lab and the prototyping in small groups to becoming a more mature, deployed production platform. So really standardizing around that for deep learning, and in people really wrapping their minds around the idea of we don't kind of come up with the design, we more get that raw from the data through the deep learning process. So it's been the time that kind of your product people and business managers and GMs start to get the idea that
the rules and the deep learning can come up with the design for the prediction from all the data we have now.
Thank you very much. I'd like to take a question from audience. If you have a question, go ahead and raise your hand. And if not, I'm going to go into a second question. Oh, yes. And you have a, oh, and then let's get you a microphone over there.
So following up a little bit off of Matilda's comments about communicating the science to people who aren't experts, to what extent in your current companies and also in previous companies you worked at, do you feel like the business side of the company, the executives, understand the value of what you're doing and of the data, or do you have to constantly sort of prove it and explain it to them?
So we are lucky in that our chief science officer, she was a grad student, got her PhD here, and then postdoc in Stanford, and she's C-suite, so she's really high level, and she's able to convey all these ideas, so we have a strong support on that end. We're really proud to say that we're evidence-based. We do journal club every week. We really look at peer-reviewed papers. So when I left my postdoc here, my mentor was like, "Hell, you're going to the dark side. You're not going to do science anymore?" I'm like, "No, actually we do still." So they do understand the value. The main issue we had the last month or so, we're trying to explain to doctors, we're like, "Oh, this patient is at risk." And maybe if they think that our models is just too black boxy, it's like, how can we interpret our models? Maybe you have the best accuracy ever, but if nobody believes in your model and if you cannot interpret anything, this is going to be an issue. So it's the same comment that we have for the business part of the company. So we're trying to think about shape value or that kind of thing to better explain.
What skills are you and your team most interested in building right now?
So my group works with we're very customer facing. We work with a lot of large banks. We go in and we help them build out models that run on our platform that help them monitor their employee communications, looking for problematic behavior. And so the skill set is a combination of both being, very technically sound, adaptable when new technology comes in, ready to learn, ready to adapt, but also really good customer-facing skills, good communication skills. So similar to what you were saying, being able to explain what's happening. If you give them something that you can't explain, then they're not going to accept it. So it's an important combination of those two things: very technically sound, but also very person-oriented, able to explain to technical and non-technical audiences.
So we're a healthcare company, technology company, analytics and software. So it's really making use of all this data that is in various forms of quality. So the big challenge and skill that continually comes up is asking the hard questions of the data, being able to really diagnose the issues of where the gaps are and how limitations in the data will affect your model. So that you can improve it over time, and then identifying other data sources to be able to bring in to be able to solve some of those challenges. I'll also reiterate that communication skills are so important. We take for granted how much we know about the accuracy of the models, and it's a continual challenge to be able to kind of communicate that, make it transparent what the model's doing, build trust, and really take apart that black box for people and have them be able to understand really make it meaningful for them.
2019 for Axel Healthcare is going to be a change in that we would like to attack NLP. Nobody's doing NLP so far, but we would love to get medical notes from doctors, and mainly we having pharmacists who call providers, so we record all this audio phone call, and we'll think about AWS transcribe. We could transcribe it and then do some NLP processing to learn more about receptivity of that kind of thing. Right now we had like an intern who would go calls by calls, listening to them, and manually ranking. So if we could automate all that, it's going to be a new challenge. And none of the data scientists has been doing NLP at Axial yet. So yeah.
So at Mira, we're still trying to develop the whole product. And can everyone hear me? Okay. So the most important skill at this juncture is actually data engineering, and that is building productizable software. And I see that as a natural progression of a company in which first you start out with no product and you need to actually build the infrastructure and the software itself. So we're currently at that stage, and data science becomes a role that is more synonymous of data engineering at this stage. And so I occasionally lament my inability to write code that interfaces perfectly with Amazon Web Services. So our data engineering staff right now is short. We lost one person a few months ago. And so, so this illustrates the point that when you're trying to build a product in the early stages, you really need to build the infrastructure. And at a later stage, when you have the product and the company is reaching a hyper growth phase, then you see a gradual transition of data science into more product management and product development, in which, as the other panelists have said, the asking the right data questions and being able to communicate it with external clients become more important. And so this is the general trend that I'm seeing in my present and previous work experiences.
So perhaps one take-home is that depending on sort of the maturity level and how long a company's been around is really going to drastically affect what kind of background you need to have. Because we have representative, so in digital reasoning, a long standard technical company, you all started out as being differentiated by your data science and by your analytics. Change healthcare, first started as just managing, the transactions, but now has started to be known for its data science and using that data that flows through. And then we have Axial Healthcare, which also started out in sort of a mid, sort of like a teenager or young adult technology company now.
I started 2.5 years ago, and we were like 35 employees. Now we're more than 100, and we're expecting to triple. So I came when data science meant SQL, period. All right, for the first year, and now the whole team is like using R every day, and like going into predictive modeling instead of just descriptive. So I've been through that transition.
Fantastic.
With the company.
And then Mira brand new, but starting out, with sort of the deep technical. So fascinating. Thank you for that view. I'd like to take a question, another question from the audience, if there is one. Yes, can we get a microphone in the back here?
Given your own disciplinary backgrounds, what have been the most challenging aspects of interdisciplinary hands-on work in the process that has led to now call yourselves data scientists?
For me, so I transitioned from academic work into data science, and there was a lot of overlap there. I was already familiar with like some, I was writing my own code, I was doing research, I understood a lot of the underlying concepts and everything just fine. But there was a lot happening out there, and it was all happening very fast. And so just trying to like take that in and understand what's the most important stuff to focus on. I leaned pretty heavily on my network. I had other friends from academia who were exploring other areas of like, basically the tech sector. And so I just connected with them, got a lot of feedback, a lot of really good advice, and said, okay, I'm gonna go here, here, and here, and that's what's gonna pay off for me. So, and then it's like a lot of self-discipline to learn new things, right? If you're gonna make a transition like that.
Matilda or Sharon, would you care to?
So I think that the two main things that will change from an academic career, first it's the pace. Like here you would say you really want to have the best model ever, and if you're going to have to work on it for 3 years until you get your publication, you're going to do that. On the other side, in the dark side world, as they say, you're going to have the business development who say, we promise our client we want a solution by May 1st, and you're going to have to give us what you get at that time, and you have to let go of, this is not perfect, and eventually you're going to reiterate and improve the model. So that's something at first from the academic world is like a little bit unusual. The second thing is, when I was a postdoc, I was collecting my own data. I knew profoundly, like, what would be, like, I knew everything about the data because I collected it myself. And so, yeah, you know how good it is or not from the beginning, you understand way faster. When, like my new position, we're dealing with medical claims, you have to understand that some doctors won't code the same way, like you have to understand that whole new world, and you have missing data, or maybe they redacted the data, and you don't know that after like several weeks, so you may lose quite some time there. Those are the two main things.
Yeah, so echo Matilda's point about having to let go of perfection, because deadlines are always looming. And sprint cycles in software usually mean a 2-week cycle. And in my case right now, it's 1 week. So we need to finish projects and scripts in 1 week. And it's less of a matter of getting the model perfect, more so than having your teammate being able to reproduce your results, which means that documentation in code becomes tremendously important. And this is something that I did not think about in academia. Nobody needed to run my code, but now my 5 teammates need to be able to run my setup and know exactly what's happening at each step and know what my variable names mean. And so I need to think about that now.
So a quick question. Oh, did you want to?
I was just going to kind of reiterate on there. I think in the last week and a half, I've heard this phrase, the perfect is the enemy of the good,
And
2 times in different meetings in the last week, so kind of reiterating. But yeah, developing that sense of the value of what you're deploying as seen through the client or customer's eyes is huge. Because in a lot of cases, you're replacing something that could be a rules-based system, or there's a lot of human interaction. So that extra 0.1% of improving your model means less than getting the model trusted and out there and starting to be used and iterating on it.
So quick question. And if you would raise your hands, and we'll take a question up here in just one moment. How many people here actually are currently using Git and GitHub? All right, so good. That's good to see. How many people here are familiar with Agile or Scrum? Also, perhaps a bit more. Maybe not everyone. Any other specific industry sort of knowledge or skill that you think that someone should absolutely know? And if not, that's fine.
I have to say SQL and data analysis.
Good.
Just to go
right,
back
there's perfect. How many people know SQL? More than I would have expected. A lot of folks actually, because a lot of people don't have databases, in research. They're your spreadsheets that you have to get to. Yeah. So, quick question.
Yeah, a few years ago, somebody said to me that the top people that are winning the competitions, the data science competitions, you'll see something happening over and over again, is that they get very deep into the data. They parse every nuance of it and really ask questions of it. And you have to know your data very well. And a lot of times that means the basic block and tackling of SQL querying and asking data questions.
So question here.
Since you guys brought a very interesting aspect of the difference between the academic relaxation versus the demands of the commercial environment, data science happens to be one of those odd fields where a lot of things that we have learned from the academic worlds have now been pushed or being utilized for the commercial advantages without a genuine oversight, unlike, say, biochemical research, which makes it through the FDA to the people's consumption. How do you overcome your hesitancy, knowing very well that what makes the academics so much slower is there is a tendency to be double sure. The rigor that goes into it ensures that we don't publish, because you have to own it for the next thousands of years. Once it is published, it is out there, and you would be critiqued in your own lifetime. So it's a genuine fear for everybody in academia. Whereas your 0.1 version of the code, while you have the chance to improve upon it, there are enough people whose life might have been altered based upon somewhat suboptimal code. How do you develop the habit of overcoming those biases one way or the other? How do you train yourself for that?
I'd say you put the model that doesn't have 0.1% out there so that you save some people, and then you improve on it 6 months later and you save more people instead of waiting 2 years to save people. So that's one thing. We do publish in peer-reviewed journal too, so like it's part of our work too. So there's a little bit of still academic ties in what we do. But yeah, I mean, it's like you wait 2 or 3 years to publish something, to have a perfect model, or you have an imperfect model that still does the job for some patient in our case. Yeah.
And one differentiator when you're creating models that will be used, I know this is an experience that you all have, is you can actually quantify the value of this model. You can quantify in terms of number of bad actors that are likely to be captured versus not, or number of overprescribers for opioids that are likely to be caught or not, or improvement in learning, or improvement in efficiency. And sometimes you can actually put dollar amounts, and that's something which is always a powerful thing. Rather than just saying, hey, your AUC is 0.79, is it good or not? You can say, this model is going to earn you, $300,000 a year. If you put it into place, it'll cost you $400,000 to implement it, so you make the call. So then it makes it a little bit clearer. So you don't just have to say, oh, I want the model to be better. You can make the business or the clinical decision to say, now is the time to go because. Let's go and take 1 or 2 more questions here. Yes?
Hi. So the question's for anyone in the panel. If you've come across any ethical dilemmas, you take the Hippocratic Oath. You ever, in the course of your day-to-day jobs, your workflows, come across situations where data science actually maybe isn't the best approach?
I can't say ethical dilemmas directly that way, but I will say that HIPAA law is very rigorous, and compared to other industries, it really restricts a lot of what you can do with patients' data. So working within that framework deals with some of this, and then on the other hand, working with provider and payer data use agreements, they do address a lot of this. So that deals with a lot of the frameworks of the ethics right there.
So not ethical per se, but Mira is working with a lot of recorded speech data from children. And so a lot of privacy issues are in fact related. And so right now we're always trying to get the school district's permission and go through the entire IRB approval process to be able to get someone into the school in the first place, right? To have them read to the software. And so, yeah, we're definitely very cognizant of that and making sure that the children's PII, their personal identifiable information, is all secure, under wraps.
Yeah, data security is a very important thing. In the financial services world, the banks actually own all their data and they kind of control all that. Anybody who works with them has to go through all sorts of training and compliance modules and stuff like that. It's incredibly regulated, similar to healthcare. And so anybody who's actually getting to work on any of those projects is going through a lot of ethical training. That said, I don't think we've encountered any like decision making on our side that would also be an ethical choice. I mean, like, you know, there's the data security side of it and personal privacy side of it too. But just like, do our models make decisions that could be problematic? That's I think another ethical question. And should we allow them to do that? The way that our system works is that we're surfacing alerts to humans, to compliance officers, to do future, further review and investigation. So it's basically helping weed out a lot of stuff to save them time and effort so that they can do their job better, but not actually making those decisions.
We have time for one more question and
Yeah.
then just brief responses.
Yes. I'm wondering if you could travel back in time when you first started working with data and give yourself some advice about what to pay more attention to or what to pay less attention to. What kind of advice would you give yourself?
Nice question, Mary.
I would say try to focus less on the tools and more on the concepts behind the tools. Tools change over time and skills can be learned with those. But the fundamentals of being able to diagnose problems or to creatively think through what other resources you need to bring in to improve your project, that never changes. And the different resources that you could apply do keep changing. So I would say those kind of fundamentals to focus on.
But I would just add to that, at the same time, you want to go in and get it working too, to make sure that you know how to do it. Because those tools are going to change and there's a lot of ways to solve the same problem. If you don't understand it or you don't understand those fundamentals, maybe you'll get lucky, but you want to focus on that first. But also just getting your hands dirty and seeing where does it fail. Going back and fixing that and iterating until you get comfortable with it.
So being able to be patient sometimes when there is no eager customer really wanting to use this particular model you're developing is important. When I started my first job, the very first project, it sounded so promising because everyone at the company kept saying, 90% of the customers only have their electric meter measured once a month, and if we have a meter data for every hour, this is going to open up all kinds of interesting analytics avenues. And yeah, so I developed a model that would impute smartly based on the building types and other characteristics of the businesses using the energy. And so for about 2 years, the model was just sitting there because there is no customer actually really wanted that function until a school district in LA was really intent on, okay, we need to know exactly what's happening in our schools. And so their monthly meters, okay, yeah, that suddenly became useful, but that was 2 years into I started my first project. So in the meantime, you just always have to keep an eye on the most pressing need, so to speak. And a lot of the times, it's also being able to read what is in your boss's mind, in your boss's boss's mind, in their product teams that they're mostly working closely with, because a lot of the times they make the decisions of what to push into the customer space. And so yeah, you kind of need to be able to keep your mind open on what to work on to make the most impact. Or otherwise, also be content working on what you think personally is important as a pet project in the meantime. And it's a balancing act.
Well, I'd like to thank our panelists. Thank you very much for taking time with us. And we'll move on now to our